can't be here, you guys. I took my daughter to the doctor on Friday. They told me there was not really anything they can do, and now here I am. She got sick this morning, so I came in and recorded this for you guys, so hopefully you have some understanding of the lesson. So this is all about function operations. So, and I'm recording with my 2-year-old sitting in the seat. So if you hear random noises, please try to understand. So right here, this is just showing you that if you want to add, subtract, multiply, or divide functions, that's like literally you just take the two functions and you divide them, okay? So like in this here, if I see this notation, it really means just take this first function and add it with the second function. And remember that f of x and g of x are just their names. So all of this, subtraction, multiplication, division, you see it's the same as doing them separately. So what that means is if we have given to us f of x and g of x, then we can go ahead and do the following. And if I'm going too fast at any point in time, you guys relay to the sub to pause the video. So f plus g of x really just means take the f of x function and add it with the g of x function. So we're going to take 5x cubed plus 1, that's the f of x function, and add it with x squared minus 4, following normal procedure for combining like terms. So we have a cubic term, we have a quadratic term, and then the 1 and the negative 4 would combine to make our constant term. And this new polynomial is f plus g of x. We would follow the same rule for subtraction. And when we follow the rule for subtraction, we're going to take f of x, and we're going to subtract g of x. Make sure that we distribute that negative so we fully understand that this is a minus x squared and a plus 4 being combined with the other terms in the polynomial. So again, we have a cubic term, we have a quadratic term, and we have a constant term made by adding those two constants together. So this polynomial represents f of x minus g of x, or f minus g of x. All right, the next two are multiplication and division. So for multiplication, we would take f of x, we would multiply it times g of x. Okay, so we're going to take x squared plus x minus 6 and multiply it times x minus 2. And then don't forget that you have to distribute the x to every term and then the 2 to every term. So we're going to have x cubed plus x squared minus 6x minus 2x squared minus 2x and plus 12. And then again, we have a lot of like terms to combine. So we have a cubic term, we have a quadratic term, we have a linear term, and we have our constant of 12. So this new polynomial is f of x times g of x. The next thing we're going to do is we're going to divide. So we're going to take f of x and we're going to divide it by g of x. So we're going to take x squared plus x minus 6 and divide it by x minus 2. If the numerator is factorable, that's a quick way to go ahead and divide, because you can just cancel out the common factor. And in this case, it is. And if it wasn't, then you could use synthetic division or long division to figure out your result. And so those are the 4 basic operations: adding, subtracting, multiplying, and dividing. Now we're going to talk about a different thing called composition of functions. Okay? And with composition of functions, notice the notation is a little bit different. First of all, it has this like open circle thing. That is not a times symbol. That means composing the functions together. And notice that when you look right here, you can see that composing the functions together means that one of the functions is what's being plugged in to the other function. So, for example, normally, if you guys calculate something, let's say that f of x equals x squared plus 2x plus 1. So you're used to doing something like f of 3. This basically means everywhere there was an x in the problem, you're now replacing it with 3. So 3 gets plugged into all those places where x once was, and then you finish your calculation. In this case, we would get 16. So we would get that f of 3 is equal to 16. Now let's think about this if it wasn't f of 3, but instead if it was something like f of x plus 2. So they can write something in here that's more complicated maybe than what you're used to seeing. So it seems weird to see an x plus 2 in there, but the same procedure takes place. And I'm sorry, this should have said squared up here from the function. But basically, that means everywhere there was an x, you're replacing it with an x plus 2, and that means you still have to square it and do all this other stuff. So you'd have to square this polynomial. So you get x squared plus 4x plus 4. You'd have to distribute this 2. So we're going to have x squared plus 6x plus 9. That function is going to be f of x plus 2. So notice I wrote the x plus 2 here for you. Now, if I wanted you to plug in x plus 2 and I didn't want to write it, then what I might have done is instead given you two functions to start the problem with and said one's called f, and it's x squared plus 2x plus 1. And then the other one's called g, and it's x plus 2. And then instead of saying calculate f of x plus 2, I might say calculate f of g of x. And you'd say, oh, gosh, like I have to plug in g of x to f of x. But you would just replace g of x with the x plus 2, and you'd be doing all the things we talked about before. So let's look at this. So here we're going to calculate f of g of 3 and g of f of 3. So first of all, understand that f of g of 3 could also be written like this. Okay. That means that first you're going to calculate g of 3, and then that result is going to be plugged into f. So I'm going to look first at what g of 3 is. And in this case, the g function is taking x and cubing it. So I'm going to replace the x with a 3, and that comes out to be 27. So that means back here, g of 3 can be replaced with 27. And now my final answer is dependent on me calculating f of 27. So remember that f of something meant we took the something and squared it. And so in this case, we want to plug in 27. And our answer is going to be whatever we get when we square 27. So 27 times 27. So 729. So f of g of x is equal to 729. But now it also asks us for g of f of x, which is in the opposite order, or g of f of 3, sorry. So this time we're going to do g of f of 3. Again, this means we need to go figure out f of 3 first. So f of 3 is going to be to take 3 and square it, which is going to come out to be 9. So then what we're essentially doing is calculating g of 9, since we figured out that's the replacement. And g takes numbers and cubes them, so we're going to plug in the 9 and cube it, which again is going to give us 729. Now don't be fooled, they don't always work out the same way. These ones did because of some exponent rules. So part B over here refers to some set notation. So I just want to make sure you understand the set notation. The function f really only consists of 3 different rules or 3 different points. That f of 1 is equal to negative 7, f of 2 is equal to 3, and f of 3 is equal to 0. I knew all of this by looking at the 3 points in the f function. The g function only has 2 points, or 2 rules. G of 0 is equal to 11, and g of 3 is equal to 1, and those are from the 2 points in g. Now I'm going to use that to help me do the calculations. So the first calculation is to do f of g of 3. Now remember, that means we're going to find g of 3 and replace it into the f function. So to find g of 3, look over here, see that g of 3 is equal to 1, then that means I'm replacing g of 3 with 1. And then to find my final answer, I need to look at f of 1, and up here I can see that f of 1 is equal to negative 7. So this is just a different way to do it if they give you some written out sets. Okay? So if they give you the whole set, then you can do it that way. The second problem is to calculate g of f of 3. Again, remember that means we're starting with f of 3. So take a look at what f of 3 is equal to, which is 0, which really means for us we're calculating g of 0. And then if we look at what g of 0 is here, that really means our answer is just 11. Okay. All right, the last thing we're going to do is what if you have to find g of h of x or h of g of x? And remember, the letters are all just names, so they could use any letters that they wanted. So I'm going to address part A, and we're going to look first at g of h of x. So remember, this means that we're plugging the h of x function into g. Now remember, we talked about you might freak out about that because these are all names, like, what is h of x? But we have what h of x is listed above, no matter how simple or how complicated it is. So if we look at h of x here in the first problem, part A, it says h of x is negative 3x plus 1. Now that whole group of stuff, just like if you were calculating g of 5, okay, you would just plug 5 in everywhere x was. It doesn't matter how complicated I make all this stuff you're plugging in. You're following the same procedure. You're going to take the g function and plug this negative 3x plus 1 in where x is. So if you struggled with this, my advice to you would be to take the g function and write it with empty sets of parentheses where x is. So here's our g function, negative 2 times an empty set of parentheses squared. Now our empty set of parentheses in this case, we're going to fill in with exactly what the problem's told us to, which is negative 3x plus 1. So we'll be done with this problem when we finish this calculation. So first we need to square negative 3x plus 1, which is going to be 9x squared minus 6x plus 1. Then we need to distribute the 2, which is going to be negative 18x squared plus 12x minus 2. This is our final answer because it's as simple as it gets. So this is g of h of x. So the next thing we're going to look at is kind of doing the reverse order of that. We're going to look at doing h of g of x. Okay. So h of g of x. Again, remember our first goal is to replace the g of x. And that g of x is just a name, and we want to replace it with what it says its function is. And so g of x is listed as negative 2x squared. Now, to do this properly, what we're going to do is we're going to take the h of x function and write it over here without any of the x's. So the h of x is negative 3 times an empty set of parentheses, where x would be, plus 1. And then we're going to plug in everything that we've listed here, our negative 2x squared. And then we're going to go ahead and we're going to do the arithmetic. So this would give us 6x squared plus 1. And that's equal to what we started, which was h of g of x. Now, you might think like, oh, I got the two answers, but I called the other one g of h of x, and this one, like you mixed up which one was which. That is a big deal because it means you're not plugging the right function into the correct function. So if you're getting those mixed up, you will miss that whole problem because you're not interpreting what it's asking you correctly. So make sure you understand that that's not a small deal. It is a big deal. All right, so we're going to do this again for the last one. So g of h of x. Again, remember that means we're going to take g of, and we're going to plug something in for g. And in this case, h of x is x minus 3. And what the g of x function looks like is just the absolute value of x. So it has an absolute value around whatever you plug in for x. And then we're going to go ahead and plug in what it said to plug in for x. That can't be simplified at all. So our final answer is that g of h of x is equal to the absolute value of x minus 3. Then if we look at it from the other perspective, h of g of x. Okay, again, remember that means that we want to replace g of x with its function value, which is the absolute value of x. And h of x as a function looks like some value of x minus 3. And now I'm going to replace where x normally goes with the absolute value of x because that's what's being plugged in. There's nothing more that we can do. So h of g of x is equal to this absolute value of x minus 3. All right, so your homework tonight is going to be the homework that goes with this section, which I believe is homework number 6. You guys can start it in class. There are textbooks around the room, not a ton, but you can take a picture of the page that you need, and then you can use the picture to do the rest of the problems. And then I should be back tomorrow, as long as my daughter doesn't wake up throwing up again. And what we'll do is we'll go over this assignment, and we'll do an activity. Then you guys will have video notes at home. Your test is still going to be set for Friday of this week. Okay? Have a good day, guys. Sorry I couldn't be here. Bye.